Welcome to your competitive exam preparation session. Today, we are diving deep into percentages, and by the end of this lesson, you are going to walk away with complete clarity on this topic. So let's get started. Now, what exactly is a percentage? Simply put, percentage means per 100 or out of 100. The word itself comes from the Latin percentum. Whenever you see a number followed by the percentage symbol, it's just a fraction with a denominator of 100. For instance, 20% literally means 20 out of 100. In all our calculations, the base value is always assumed to be 100. This is your anchor fact for this topic. Why do we do this? Because percentages are primarily used to compare quantities on a standard scale. Imagine trying to compare a student who scored 45 out of 60 with another who scored 70 out of 90. It's confusing, right? But if we convert both to a base of 100, that is, percentages, the comparison becomes instant and crystal clear. Both actually scored 75%. Understanding this core concept of the base of 100 is the secret to solving complex arithmetic problems quickly in your exams. We will build everything upon this simple foundation. Now here's the key thing that separates average students from top rankers: speed. And speed in this chapter comes from mastering the conversion of fractions to percentages. To convert any fraction into a percentage, you simply multiply the fraction by 100 and add the percentage sign. It is that straightforward. Let's break this down with a very common example. If you have the fraction a quarter, you multiply it by 100, which gives you 25%. Similarly, if you take 1/3 and multiply it by 100, you get 33.33%. Now, think about this for a moment. Why does this matter for your exam? In competitive exams like SSC, CGL or banking, you don't have the luxury of time to calculate these basic values from scratch. Memorizing standard fractions saves crucial exam time. When you see 1/6 in a word problem, your brain should instantly register 16.66%. When you see 1/8, you should immediately think 12.5%. I highly recommend creating a chart of fractions from a half down to 1/20th and pasting it on your wall. This simple habit will drastically reduce your calculation time and give you a massive edge over your competition. Let's flip the script and look at the reverse process. Converting percentages back into fractions is just as important, especially when dealing with complex data interpretation questions. To do this, you simply divide the percentage value by 100. Once you divide, you remove the percentage sign and simplify the resulting fraction to its lowest possible terms. Let's look at a practical example to see how this works. Suppose a question mentions a 40% increase in a company's revenue. You take 40, divide it by 100, and simplify 40 by 100 to get to fifths. Working with the fraction to fifths in an algebraic equation is much faster and less prone to error than multiplying by 0.4 or dealing with decimals. And this is where it gets really interesting. What about those tricky, non-terminating decimal percentages? For example, if you see 16.66% in a question, you should instantly know that it translates directly to the fraction 1/6. You absolutely do not want to be dividing 16.66 by 100 manually in the exam hall. That is a classic trap set by the examiner to waste your precious time. By converting percentages into simplified fractions, you turn complex multiplication and division into basic mental math. This technique is the absolute backbone of solving profit and loss, simple interest, and ratio problems efficiently. Moving forward, let's tackle a concept that appears in almost every single competitive exam: percentage increase and decrease. Whether it is a population growing or a price dropping, the core formula remains exactly the same. The basic formula is the change in value divided by the original value, all multiplied by 100. Let's break this down further. If a value goes up, you calculate the percentage increase by subtracting the old value from the new value, dividing by the old value, and multiplying by 100. For example, if a product's price jumps from 50 rupees to 60 rupees, the change is 10. So, 10 divided by 50 times 100 gives a 20% increase. Conversely, if a value drops, the percentage decrease is the old value minus the new value divided by the old value multiplied by 100. If that same 50 rupee item drops to 40 rupees, the change is again 10. But 10 divided by 50 times 100 is a 20% decrease. You must remember one golden rule here: always calculate the change relative to the original base value. The most common mistake students make is dividing by the new value instead of the old one. Always ask yourself, what was the starting point? That starting point is your denominator. Now, what happens when a value changes not just once, but multiple times in a row? This brings us to the concept of successive percentage changes. This occurs when a value is changed by a certain percentage, and then the new resulting value is changed again by another percentage. For example, a shopkeeper increases a price by 10% and then offers a 10% discount. Are we back to the original price? No. To solve these instantly, we use the effective percentage formula, which is a plus B plus A times B over 100. In this formula, A and B represent the first and second percentage changes. The critical rule here is to use positive values for any increases and negative values for any decreases. So, for a 10% increase and a 10% decrease, it would be plus 10 minus 10 plus 10 times minus 10 over 100. The result is minus 1%, meaning an overall 1% decrease. This single formula is a massive time saver. It is highly useful for solving complex problems involving compound interest, successive discounts, and multi-year population changes. Instead of calculating step by step, you can find the net effect in seconds. Master this formula, and you will breeze through some of the trickiest questions on your paper. To wrap up our conceptual understanding, let's look at the specific types of word problems examiners love to test. You will frequently encounter election problems, where you must calculate the total number of voters based on valid versus invalid votes and the winning candidate's margin. The trick here is to always assume the total voting list is 100%. Next, we have examination problems, which require you to find the passing marks or the maximum possible score based on a student failing by a few marks or scoring above the threshold. Again, setting the maximum marks to 100% or X is your best strategy. You will also see Venn diagram problems, which deal with groups of students passing or failing in multiple subjects like math and English. Finally, there are income and expenditure problems, where you track a person's spending on rent, food, and transport to find their final savings as a percentage of their total salary. We will practice all these types extensively. And that wraps up everything you need to know about the foundational concepts of percentages for your competitive exam. In our next class, we will be moving on to advanced problem-solving techniques and shortcuts, so make sure you stay tuned. And if you haven't already, download the Examiverse app It's your complete preparation companion for cracking your exams. We'll see you in the next class.